108 times 2 times 4 is equal to 1 inch cube. So the shear at B, just by looking at the web, is equal to, again, 2.75 times 10 to the power 3 V over by I, 233 over 12. Then your Q is 1, thickness is 1 over 8, right? So 2.75 power 3 times 1 divided by 233 over 12 divided by 1 over 8. So it's equal to 1133 psi. Okay. Then the next one, we will look at this point over here, right? So this point over here, oh, it's a mess. I do apologize. This point over here, I'm going to call it our shear at point B, plus by the web plus flange. Okay, that's the point over there. So yeah, isn't it obvious, right? So the only thing that changed the Q, right? So shear at point B will be with the web plus flange. So the Q over here will be equal to, if you look at the web, so it's 3 over 2, sorry, the flange. So this is the Q of the flange plus by the Q of the web. Okay, so this will be equal to 3 over 2 plus 1, right? So this will be equal to 5 over 2 inch cube, right? So the shear, including at point B, you'll be including the web and the flange. So this will be equal to 2.75 times 10 to the power 3. Okay, 2.75 times 10 to the power 3 multiplied by 5 over 2 divided by 233 over 12, 1 over 8. Okay, so 2.75 times by 5 over 2, 233 over 12, 1 over 8. So it's equal to 2832 psi. And finally, okay, now you don't need to find point E, right? Point E you don't need to find. Why? Because this value over here, right? Remember, the analysis starts from outside, come in. It cannot cross the what? It cannot cross the centroid. So for that fact, this is also equal to the shear at point E. Okay, for the flange, this is equal to shear at the point E of the web. And this is also equal to the shear at point E, including the web plus flange. Okay, right? I know the arrow is flowing towards them, but the analysis, like the rules, remember what I said, the rules start from outside, right? The centroid is still the centroid is the datum, but the analysis start from the maximum Y max. Okay, so for that reason. And then finally, some of you say, thank God, finally. The tau max is at the what? At the centroid. Right? The tau max is a centroid. So I'm going to get this image over here. I know this is one of the most boring lectures that I've given you. I understand that, okay? Right. So this is where point C is now. Okay, so it's at the centroid. So the Q will be equal to the Q of the web plus flange plus by the Q of the Q at the of the web. Okay, of the web to centroid. So is this region now? Okay, so this will be equal to 5/2 plus by the width multiplied by the depth multiplied by the centroid. Okay, because the distance from here to here is 3, right? So this will be equal to 18 times 3 times by 3/2 plus by 5/2 is equal to 49/16. Okay, 49/16 inch cube. So therefore, tau max will be equal to 2.75 times 10⁻³ divided by 233/12 multiplied by the first moment of area and then 1/8. So this will be equal to, where am I? So this will be equal to 2.75 power 3 times 49/16 divided by 233/12 divided by 1/8 is equal to 3470 psi. Okay, so this is the end of shearing stress. One of the most difficult topic, but I hope you guys do enjoy it. Okay, do enjoy it. Now, on Thursday, we're going to analyze structures that are under bending moment, axial loading, and shearing, and also torsion. Okay, where if that's the case, I'm going to stop here. Anyone, any questions before I let you go? Anyone, please.
Eugene?
Yes.
What content does our midterm end at?
So will be whatever I teach until before the midterm. Okay?
Okay, thanks.
Thank you. Anyone else, any question? If no, I'll see you guys on Thursday. Thank you. Bye.